Let's discuss a question from heat transfer. This is a question on lumped heat analysis. Okay, and as you know that lumped heat analysis itself, the word indicates that the temperature of the body cools uniformly or the body heats up uniformly. There is no spatial distribution of temperature. Now this entire thing is dictated by Biot number, okay, which is given by h characteristic length by k. Now this characteristic length is again volume by area. Now this can be considered as the convection happening from the surface, convection heat loss from the surface or heat gain from the surface to the liquid. So it can be heat loss or heat gain, okay, by conduction within the conduction heat transfer within the solid. So this can, there are two examples, like basically two examples. You have a hot body getting cooled or quenched in a liquid medium, so liquid or air medium. So the surface gets cooled first, and because there is a thermal gradient that arises because of thermal conductivity, the temperature, there will be some temperature difference between the outer surface and the innermost. The innermost cools at a later time. But if my conduction is very high, if my conductivity is very high, then there will be the difference at the outer temperature, outer surface temperature will be almost closer to the center temperature. There will be very less thermal gradient that will be existing within a solid. So the conduction heat conductivity will be very, very higher, okay, and that is the case where you have lumped. This is the case where you have lumped heat transfer, okay. So for lumped heat transfer, ideally k should be infinite and Biot number should be 0. That is the ideal case, okay, because if k is infinite, there will not be any temperature difference between the outer and the inner. Both the entire body cools, like if in this quenching example which I told you, the entire body cools at a uniform rate. There is no temperature gradient that exists. So ideally that is the thing. So okay, so if k has to be very small and Biot number obviously k has to be very large and Biot number has to be very small, has to be 0, but that is hardly. So k Biot number is very, very small if k is very large, okay, and that corresponds to lumped heat transfer analysis. Thank you. So the answer for this is A. Thank you.